the flow nets through earth dams. What we need is a phreatic surface. When you are talking of flow through earth dams, the top flow line is not defined. So what we say is, what is that line which is maximum or at the highest point, and we call that as a phreatic surface. The characteristic is the potential or the head pressure head is 0 at every point along that. Above the phreatic surface, the soil is in suction or is exposed to the surface. So what we say is that the potential is equal to the elevation, the h, or h is equal to y or z. And we also say if the head is equal to y, the gradient is along the flow net, so there will be no flow across the phreatic surface. So here is a dam and we have a reservoir, so we would like to know what will be the top phreatic surface. Just to illustrate, we are putting a drain so that we don't want the phreatic surface to hit the downstream surface. So you can see, if I take a molecule of water, it will flow along and then it will not hit the downstream because there is a highly pervious medium, so it will try to come down. And once you fix this, the other flow line is at the bottom, so I can draw any number of these flow lines. All the water traveling through the dam, it gets collected into the drain. And once you do that, you can draw the equipotential lines for the earth dam. And here you can see 1, 2, 3, 4. It's not a very good flow net, but just to illustrate. And you have how many draws? 1, 2, 3, 4, 5, 6, 7, 8, 9. So you know the number of flow paths and the number of. If you don't have a drain, this is what is possible. The water will come here, go down and hit the downstream side, and then it will flow along it. This is a very dangerous thing because the soil here becomes very soft. So I always recommend that you have to provide a drain. This illustrates how you can draw the phreatic surface which is hitting the downstream side. And then these are all our equipotential lines. If you have a drain which is going right into the dam, which is a very good one, you can see that the flow is collected and the downstream face will all be dry. And this is how you can draw the flow net for a long drain. If there is no drain, this is what could happen. So unless you have a drain, it's not a good thing. So this is a drainage blanket, and if the flow is taking place through the foundation also, we can combine the two and then say this is the phreatic surface, this is confined, so we can have the flow net for the two cases. And here is the flow net for flow through the embankment and through the dam. Please remember, this is our phreatic surface. So the head here is full, and if I look at it now, 20% less, 40% less, 60%, 80%. You have divided the whole thing into equal increments, and I know this equipotential line, this is 100% potential, this is 80% potential, 60%, 40, 20, and of course 0. So this is 15 meters of water, this will be 12 meters, anywhere along this, 9 meters, 6 meters, 3 meters, and of course 0. So these are the values of the head along each of these equipotentials. This is for a well point, you can have similar one, we do that.